In this video, we're going to go through Learning Target 4.3.3, which is simplifying expressions using exponent rules. So we've already learned our 2.0 level exponent rules. And so those ones is just like one step to solve. And so what we're going to do now is kind of add a few steps to that. And so we're going to add like a step or two to the difficulty level. And it's the same 5 exponent rules, but we're just like putting more than one together in the same problem. And so we are going to look at this table. And if you don't have this packet, you can just fill out this table as we go. You're going to need 6 rows. 1 is the title, and 3 columns. And so if you want to pause it and fill out this table, and then we'll go through it together. So the middle column is just a reminder of what the basic rule is. So the 0 rule, anything to the 0 power is 1. The negative rule, anything with a negative power, we want to change to a positive and flip it. And so what that means is if it's on the top of a fraction, we move it to the bottom. And if it's on the bottom, we move it to the top. Well, this one isn't really a fraction, so I make it into a fraction, and I'm going to move it to the bottom. When I move it, I make it positive, because that's the whole point. I want to get rid of the negative. And then since I took this whole thing and moved it to the bottom, there's nothing left, so it's just 1 over x to the m. The product rule, remember when we are multiplying our variables, we add the exponents, so x to the m plus n. The quotient rule, when we're dividing our variables, we subtract exponents, so x to the m minus n. And remember, it's top minus bottom, you have to do it in that order. And the power rule, whenever you see parentheses, you should think multiply, so you multiply m times n. So this is just a review of the 2.0 level, but now we're going to look at some more advanced examples. So kind of in the middle between the 2.0 level and the 3.0 level. So the first thing is the 0 rule. We want to be careful when there's more than one thing there of what is actually to the 0 power. So in this case, we have parentheses to the 0 power, and so that means everything inside parentheses is all raised to the 0, and anything to the 0 power is just 1. However, the 5 is not in parentheses, so it is not raised to the 0 power, so the 5 is still there. So it's kind of like we have a 5, and then parentheses, all that turned into a 1. And then you just want to simplify this a little bit. 5 times 1 is the same as 5. The nice thing about the 0 rule is that anything times 1 is just itself. So if you have more going on, then you can just like cross this out. I didn't even really need to do this step, but I wanted to show you like where it comes from. Why do we just get to cross it out? It's because anything times 1 is itself. So the 0 rule, just be careful you're not getting rid of everything and turning it into 1. If there's something else there, you have to leave it there, and the stuff that is raised to 0 is 1. Similar thing with the negative rule. So when you start adding layers to the negative rule, make sure you're only moving things with a negative power, and then anything with a positive power stays. So in this case, I would move the 4 and the x, but I would not touch the y to the 3rd. So y to the 3rd stays on top. And then on the bottom, we would have 4 to the positive 1 and x to the positive 5. Once you start getting to more advanced examples, each step you're going to want to check, am I done? Am I done? Is there anything else that I can do? And so you're kind of looking to see if there's any of these rules left, but also you're looking to see if there's any numbers to exponents, because we can do any number to any exponent and simplify that. Especially to the 1 power. To the 1 power is just itself. So we would just have 4 x to the 5th. And this is more simple than this. So you want to get to this point. When we add difficulty to the product and the quotient rule, these are pretty similar. But you just have to combine like terms. So for our like terms, we have 2 and 4 as the coefficients. And then you have the r's as the variables. imagine there was another variable, like let's say there was s to the third and s to the second or something, then that would be another set of like terms. And just do them in order. The one thing you have to be careful about is 2 and 4 are just numbers. They are not variables, so we do not do anything special to them. If this is the product rule and we're multiplying, 2 times 4 is 8. The exponents is where you get to the special rules. So because we're multiplying, we add our exponents and we get r to the negative 2. So you multiply your regular numbers, you add the exponents. So now again, I want to ask myself, is this done? Is there anything that I don't like about this? And the one thing that I notice is that we have a negative exponent that needs to be moved. And again, you have to be careful what is actually attached to the negative. That's only the r. So when we move it, we leave the 8 on top. Nothing's wrong with the 8. We move the r to the bottom. Very similar for the quotient rule. You're looking at like terms. So we have our coefficients and we have our a's. And so the coefficients, those are just numbers. We do not do anything special. It's the quotient rule, so 10 divided by 5 is 2. And then for the exponents, we subtract. Be very, very careful with negatives. 3 minus negative 1 is positive 4. You can double check that in a calculator if you would like, but minus a negative turns into a plus. 3 plus 1 is 4. Now I double check, see is there anything that I don't like about this answer? And this looks good. I don't have any negative exponents. I don't have any duplicates of variables. This 2 is by itself, so we look good. Last one is the power rule. When you start adding difficulty to the power rule, you just have to distribute. So we need to make sure that everything inside the parentheses has an exponent, and if it doesn't, we write it in. So this 3 has an exponent of 1. This z has an exponent of 1. Now we want to distribute to all the exponents. And when we distribute, we multiply. So 3 times 1 is 3. 3 times 3 is 9. And 3 times 1 is 3. Now I check to see if there's anything I can still simplify, and hopefully you notice that we have a number to a exponent, and so we want to simplify that. Please be careful with exponents. 3 to the third is not 9. Remember, 3 times 3 is 9, but 3 to the third power is 27. 3 times 3 times 3. So we can simplify that to 27 x to the 9th, z to the 3rd. And that is it. So when you're adding difficulty, we're not changing the rules. The rules are all the same. You're just adding how many rules you do in one. So instead of just doing the 0 rule, you're doing the 0 and the quotient and the negative. And so you're just kind of, each step, just do something and then see, can I do anything else? And then keep going. Hope this helps.